Well, welcome back, ladies and gentlemen. You get a chance to see me again. It is so good to see your face. Charlie, Julie, John, Linda, and Maria. We got a small class today. And Donna, Donald, Larry. All right, Jackie. Cool. Raphael. All right, ladies and gentlemen, we are at a very critical point here. I'm looking at covering the basics, the foundations of everything that you're going to be using in math and other higher levels of math, metric spaces, and also topology we're going to be looking at. When you get into uniform continuity, we're going to be using these properties of absolute value, the Schwarz inequality. All those are going to be essential into a lot of the proofs, a lot of the applications we're going to be doing. So what I'm about to go through now is vitally important things that I recognized that I needed to go back years ago and reinforce that kept popping up that I just did not have a good hold on. And so now I'm covering the foundations that you're going to need that are going to be vitally important. So let's begin. But first of all, we were asked to establish this property of the absolute value. Now from the sheet that you should have downloaded from my page, I'll give you a brief overview of those. And so now we're going to establish that property using the other alternative definition of absolute value. And here it is. The alternative definition of absolute value is given to us as the square root of x squared. So, how would you use this alternative definition to establish that this is that? There's a concept that we're going to use here. What concept am I thinking about right now that we're going to have to use in order to show that this is that? Utilizing that alternative definition. Raphael, what do you think? By George, I think you're right. Everyone else agree with Raphael. Did you hear what Raphael said? You didn't? Shout it out loud, Raphael. What concept are you going to use? Oh, it's a secret now. You want the student to figure that one out. All right. So, student, what concept am I going to use using this basic alternative definition to establish that this is equal to that? Starts with an S. What concept am I thinking? As the great Kreskin would do. What concept am I thinking about? Starts with S. Yes, I'm going to use, substitution. Let's go ahead and show that. Right now, I have the absolute value of negative x. I'm putting this in parentheses for right now. So by substitution, using this alternative definition, I can write this as negative x squared. Now, just using the definition of exponents, negative x squared is x squared. So that is equal to x squared. Ends up being an even function because I get that back. Remember definition of even functions? Well, again, we've just shown that this is equal to the absolute value of x. So we have just used that alternative definition, applied some algebraic concepts and properties in order to show this. What we have just worked on here, I have to stress this. This is vitally important. This is going to pop up again when you get to showing and proving the Schwarz inequalities and some of the other inequalities using the properties of absolute value and uniform continuity and topological concepts, and also in metric spaces as we get further into higher mathematics. These are the building blocks. That's why I'm covering them, because I realized it was important things that I missed that I want to share with you that I had to go back and review. And it's Professor Keys, who I just truly am, I'm a thanks to. He's the one that made me realize that I had to just sit back, relax, strap myself in the chair, get a cup of cocoa and a jelly donut and relax. And just take one thing at a time and think it over. And then all of a sudden I will begin to see all the things that I missed because I was jumping here and there. And when I did that, I think Professor Keys, that I started to see what he was saying, and all the things that I bypassed, jumping all over the place, started coming. I want to make sure that you see this, retain this, vitally important. Ladies and gentlemen, thank you for part A. I shall return for part B, and then we're going to move on. Thank you so much.